So on the assignment 2.1a, first line of business is this is a matching game in your book. Number 39 will go to one of these below it. So I'll scroll down. And so each one of these graphs matches with each one of these. So I'm going to be scrolling back and forth. You are to realize that this is the graph of the original function. So, and you don't need to open up your book, I got you on this. So this is the graph of f. Very important, okay? That's the graph of f. We're to match it with the graph of the derivative. So I want you to think about what that means. Sarah just said the derivative is the slopes of the tangent lines. So when you're matching it with its graph, you're thinking, what are the slopes of the tangent lines? And you're going to match it below to one of them where the y's are the slopes. So let's go over here. The slope of the tangent line right here, what would it be? Go ahead and tell me. You can see it. What's the slope of the tangent line through that dot? 1, right? It's going up 1 over 1. How about if I go here? What's the slope of the tangent line through that dot? 1, right? What's it going to be everywhere on that line? 1, okay? So for lines, their derivative graphs are actually constants. Like if I were to say, well, what's f prime of x? No matter what I put in, the slope is 1 everywhere. So I am looking for the graph of y equals 1. So when I go down below here, because again, I'm looking for the graph of the slopes. So for number 39, I would match it with b, where y equals 1. So do you see what we're doing here? Tomorrow's big task, we're going to be on some computer-aided software, and you're going to be dragging bullet points from a given function to graph its derivative. It's harder than you would think. And then you'll hit enter, and it'll tell you how accurate you are. And I'm going to have you do 3 at 80% or better, and then you can quit. Some of you will be done in about 4 minutes. Some of you, it's going to take a half hour. It happens every year. It's super visual, and if you can't see it, you have to keep trying and trying and trying. So tomorrow's notes are videoed so that if he gets done in 3 minutes and it takes her a half an hour, he can at least keep moving on. So you'll be not matching. You're going to actually be drawing with some computer software the derivatives. So let's go to number 40. This is the graph of f. F prime will represent the slopes, correct? So let's go over here. The slope of this tangent line, although I don't know what it is exactly, I know it's very negative. Would you agree? Very negative. So on my derivative graph, the y's need to be very negative over to the left, okay? And then less negative, and then less negative approaching 0. Agreed? So whatever my derivative graph is, and remember it's y equals the derivative, I need to come in from very negative, less negative, 0. And then a little bit more positive, so the y's will be climbing. It's going to have to look like that. By the way, we talked yesterday about how the degree goes down, right? So a quadratic will be linear. A linear will be constant. A cubic will be what? Quadratic. So you'd match it to a parabola. All right, this next one, so let's go see which one looks like that, where it's very negative and then goes positive. Which one of these is it? It's not B, but which one matches with that? Where the y's are negative, approaching 0, and then positive, symmetrically so. It's obviously which one? Go ahead, help me out. D, yes. That one's D. Now I have 2 others, and let's talk about those. This one right here, number 41, and again, I'm thinking of the slopes of the tangent lines. There is nothing over here. The function isn't defined. So I would be looking for a graph that's got nothing in any quadrant except quadrant 1. That automatically gives me the answer, but let's talk about why. Okay, because there's only one graph left up here. Which one is it going to be if it has to remain in the first quadrant? A. Right, but let's talk about why A is doing what it's doing. On this one, remember the y's are representing the derivatives of that function or the slopes. Y is very positive here, less positive, less positive, less positive, less positive, and it's approaching 0. So that means the slopes, it must be very, 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 very steep, close to 0. Let's go check if that matches. And this concept's tricky. Right here, if I drew the tangent line, isn't it super steep? right? So my derivative would be coming from way up above. And then it's approaching 0, like it's plateauing out. So my slopes are approaching 0. That's why it's going like this. All right, the last one, the absolute value graph. What's the slope of everything to the left? What's the slope of that line to the left? Everywhere, -1. How about to the right? 1. How about at 0? I don't know. Okay, and that's a topic for today. I don't know what it is. So that one matches to C. We're going to skip because that took me a while. You can skip 65. We'll get the gist of this later. So go ahead and just cross that off for your homework. So here we go. We just did this. I went over these. You can skip 65. We'll cover its skills in a little bit. So we're no longer going to be using that formal definition anymore. Unless you haven't done 1 through 23 odd, you're done using that. Okay, 1 through 23 odd, you must do the long way or I'll hand your homework back and it'll be considered not done. But after that, we're not going to use it anymore today. But you do need to recognize it for the AP exam. So I will tell you that's fairly easy task to recognize it. They can't test you on it because we're going to have a whole bunch of different ways. So they won't know how she's getting the derivative. And you wouldn't choose to do it the long way. I want you in your notes to go circle this. This is where you go first. They are going to lay it out for you as if you've already started doing the problem, and then they're going to stop and ask you, what was the function, and where am I evaluating the derivative at? So this is the big kicker, okay? So it's kind of like that formal definition, but you don't have to do it. You just have to pick out who's the function, and where am I finding the derivative at? So yesterday we did that. We'd get the derivative, and then I would ask you what's the slope at 1, and you'd plug a 1 in, right? So your task is to figure out who's the function. That's right here. It's what's being subtracted, okay? That's f of x at a specific spot, right? What do you think they're plugging in for x? What do you think they're plugging in for? 2. Exactly. So it says identify f of x and c. C is 2. That's the point at which this is formally doing the derivative of. And my function must have been f of x equals 5 times x squared minus x plus 7. That must have been my original function. And I can quit. They're not making me do it. They're just making sure I can recognize it. So identifying the function is usually quite easy because it's f of x plus h minus f of x. And you might say, well, there's a 1 there. That's because it's at a specific point. But I can still tell what the function is. F of is tangent. You can see it, right? So my function must have been tangent of x. And what did I plug in for x in this scenario? Because that's my c. You can see it, right, Charlie? Who got plugged in for x? You can see it. Pi fourths. And you might say, well, where is the 1 coming from? It's coming from this. It's f of x plus h minus f of x. What's tangent pi over 4, Charlie? 1. So that's where the 1's coming from. And now we're nodding. I think you're getting it. So you need to recognize it, but not necessarily perform it on the AP exam. Yes? Yes, up on the front table. All right, so the next one. Identify who the function is. It's f of x plus h minus f of x. Who's f? Who's my function? E to the x. Yeah, so my function is e to the x. This is f of x plus h. So e to the x plus h minus f of x. So minus e to the x. That means in this scenario, x is pi. What do you think about that, Marty? Pretty straightforward, right? Just you don't have to do it anymore. The next one, I can see who the function is. It's right here. It's f of x plus h. So my function must be the natural log function. And then it's minus f of x. Okay, why is there nothing there? I want you to raise your hand if you can tell me why there is nothing there. There's a good reason. I'm not moving on until somebody can tell me why there's no, this is f of x plus h minus f of x, and there's nothing there. It's because of the function, and where it's being evaluated at. Somebody tell me why there's nothing there so I can move on. There it is. Bingo. It's the natural log function at 1. So f of x is ln 1. And what'd you just say, hon? Natural log of 1 is 0. Good. You're getting better and better every day. I love it. All right, so there it is. So now, technically these don't get introduced until 2.2, and I talked about them yesterday, but we're going to use them in your homework. From after you hit number 23, you are done doing stuff the long way. We are going to use the constant rule that says the derivative of any constant, be it 5, 6, 7, 8, is 0. No matter what constant you see, its derivative goes to 0. The question becomes, why is that? And the answer is, if y is equal to 5, its graph looks like a horizontal line. And what Sarah said at the beginning of the hour when I said, what's a derivative? She said, slopes of the tangent line. What's the slope of a horizontal line? Everywhere. 0. So constants always go to 0. Okay, so I would say y prime equals 0. By the way, this right here is exactly the same thing as this right here. I'm purposely messing up the notation so you can get, they call it, the College Board calls it notational fluency, so that you're good with all notations. All right, I also told you the power rule yesterday that says that if you have, so it's easier to see it without all the variables. If you have a term to a power, you can bring the power out front and drop the degree by 1. So that would become 10x to the 4th for my derivative. Combining those two things together, if we were to take the derivative of this function, and I'll call it y prime, with the power rule, I bring this out front, I'd call it 6x. Notice the quadratic went linear. What would this one become? Minus 5? By the way, for a linear term like this, like even if it was like 3x plus 7, the derivative is always this number because that's a line and the slope is 3 everywhere on a line. It should make kind of sense why that's just a constant. And then what will the 7 go to? 0. So there's my new derivative, and that's what we're going to use today. So just make sure you're paying attention. In your homework, when do you get to quit using the long way? After what number? 23. And it'll pick up the pace. And I'm done doing it the long way for a while. All right, so next page. We've got a function g. I want us to use the power rule to find its derivative. That derivative we would call g prime. We bring the power out front. The 2's will cancel. And what's the derivative of 1? What's the derivative of the constant? 0. Okay, so my derivative, nice and smooth. That limit definition is great for the algebra, but it muddles the calculus. That's the derivative. What does that mean, Jason, when I say that's the derivative? What does that tell me? Slopes. So this is a quadratic equation. It opens up. This tells me its slope anywhere. So I would know that at 2, the slope is 6. That at 0, the slope is 0. It tells me slopes. All right, so the next question says find the equation for the tangent line. This needs to be starred. If you can't do this, you'll get multiple questions wrong on my test and multiple questions wrong on the AP test. It's a big top 10er. One of the top 10 things you need to know how to do in here. This is our first top 10er, by the way, is to write an equation for a tangent line. My Calc 2 kids would come in and go, oh my gosh, I've been doing that forever. We do it over and over all the time. It serves a purpose later, like in a real world context. So an equation requires two things. It requires you to have a point, and it requires you to have a slope, which until now you've called m, so I'm still going to call it m. But I'm looking for the equation of the tangent line, so I'm going to put slope of the tangent line just so you get that. This one handed me a point, but I need to have you change that because actually when you put a -2 into the function, a 7 pops out. So I got to make sure it's on here. When I put a -2 in here, I get 12 halves, which is 6, and I think I forgot to add the 1 when I made the notes. So the parabola goes through the point -2, 7. That's great because point slope form says you do y minus the y you know is equal to the slope there times x minus the x you know. That's great. I need the slope there. I need the slope of the tangent line. So what do I really just need? What's the slope of a tangent line? Derivative. I need to evaluate the derivative there. Equals, this was g, this would be the derivative there. So g prime of x, it would be at that point that I need. Taking my derivative equation, right? What is my derivative when x is -2? What would it be? Plug her in, right? It says it's 3x for my derivative. So this would be 3 times -2 or -6. The question becomes, can you leave it like that? And the answer is yes. Okay, you can leave it in point slope form. If it bothers you, or if you wanted to enter it on a calculator, you would want to solve it for y. So you would say -6x minus 12, and then you'd add the 7, and you could do that. For time-saving purposes, we're not going to verify it on our calculators, but I'm going to graphically show you what you just found. So there was some parabola, right? I'm just going to leave it off a grid even. It went through a specific point. That specific point was -2, 7. So go put a dot on it, label it -2, 7. I was to find the equation of this red line that goes through it. This red line that goes through it goes through the point, right? But I didn't know its slope. But my derivative gives me that. So it's basically algebra 1. But instead of being handed the slope, you have to go find it. What do you think? Could you do that? Let's go give it a whirl. On the next page, this is a huge thing for us. Can you find the slope of a tangent line? So on your next page, I'm going to go right ahead. Key concept here, whenever it's a big one, this is a big hitter. This is our first key concept we've had. Finding the equation of the tangent line. First, you need to find the derivative. Using all rules. Our rules are going to keep going on and on all through the year. Like, what's the derivative of e to the x? We'll have a rule for that. What's the derivative of sine x? We'll have a rule for that. The only rule you have right now is the power rule. So we can only do polynomials. But once you have the derivative, you'll calculate that derivative at this value. We just did it at -2. I'm going to call it at c generically. Remember, this is just your slope. This is algebra 1, you getting m. Instead of doing y2 minus y1 over x2 minus x1, you're doing a derivative to get it. And then you're going to use point slope form to write y minus the y I was given, which would be this f of c. I'm going to write y given, just so you kind of have that, but is equal to the slope there, which we will have just found it was the derivative, times x minus the x I was given. If you look it up in a book, this is what it would say. But it doesn't matter. It would say y minus the y you were given is equal to the slope there times x minus the x you were given, and they'd add that over. So it'd say y equals f of c plus f prime of c times x minus c, and you'd be going like, what? This is algebra 1, point slope form of a line. Okay, so don't worry about the c's. You just need a point and a slope. So I want you to go do 1a on your own. Raise your hand when you have it, and 1b on your own. So raise your hand when you have these two. I gave you a new g. I want to know g prime of x, a function that gives me the slopes of the tangent line. And then I want an equation of the tangent line that goes through 3, comma, I don't know. How could I find it? And I want you to raise your hand when you're done or when you're stuck. I got one. Since you're done, Carson, I'm going to look at what's on the next page in your notes because I think I might be done for the day. Oh, I'm not. Shoot. I've got 2. Raise your hand when you're done or you're stuck. 3, 4. You need a derivative. You need an equation for a tangent line. That requires a point on the curve so you know what to pass through. They said at 3. You need the slope there, which is the slope of the tangent line, which is g prime at that spot, and then you can write point slope form. You need to fill in the slots. All right, so we're going to begin. Carson, how did you get the missing part of the point? Yeah, plug it in. You're on that curve, and you're going to nick it, right? You need to know where to nick it. They only gave you the 3. Well, you have to go plug it in. What did you get when you plugged it in? 6. All right. So we've got the point on the curve that we're supposed to go through is the point 3, 6. That would be this. That's great. I need a point. I could even start writing my answer to B right now. I could say y minus the y I know is equal to the slope there times x minus the x I know. I don't know the slope there, though, right? Your hand was up, Megan, fairly early. How did you figure out what the slope there was? Yeah, the derivative, which from part A would be 2x minus 4. Right? And you just plug the 3 in. What was the slope there? 2. All right, so it requires a point. They'll either hand it to you or you do what Carson did and just plug it in and get the other plug and chug, right? You need the slope. The slope's the derivative. I had you find the derivative in part A. If you don't understand what you're finding, it just becomes a lot of what am I doing? So this is all algebra 1. Get me a point, get me a slope. The slope's the derivative. You can leave it like that. All right, how many of you had that? About 2/3. Great. The other 1/3 will get you on board. Part C. What is the value of x that makes the slope of the graph? That's not talking about g, right? It's talking about g prime. So I want the slope, or g prime, to equal 6. And you just told me up here what g prime is. So I need 2x minus 4 to equal 6. So what point would make the slope 6? The answer is it'd be at x equals 5. What do you think, Matt? It's tricky stuff. That's super important, so I'm just going to ask somebody right now. Okay, so think about this because I'm going to call you out on it. I'm going to ask you, how do you find the equation of a tangent line? I want you to write that on the bottom of your paper. I just want you to write, how do you find it? Tell me what you do, and I'm going to read somebody's. It's not embarrassing. We all love each other. But tell me what you do to find the equation of a tangent line. Honey, in your own words. Because when you get stuck on your homework, you should go read what you wrote. What do I do to get the equation of a tangent line? Most of you are writing the first thing correctly. You're right, I need to get the derivative. If they give it to me, great. If they don't, the only rule I have right now is power rule. So yes, I do take a derivative. You find f prime. Yep, I like that. Maybe tomorrow I'll give a little quiz and have you write up on an index card, a little 5-pointer, the answer to this question. How do I find the equation of a tangent line? That's a good idea, Mrs. LaRude. Thank you, Mrs. LaRude. All right, let's talk about what I'm looking for. If I give you a little 5-point quiz tomorrow on a little index card where the question is, explain to me how you find the equation of a tangent line. Tell me one thing I'm looking for. I already told you. Find the what? Derivative. Okay, I'll be looking for that. What else do you need? Who wrote something else? Because derivative is not enough. Okay, so the derivative is 4x minus 1. Super, right? That's not my equation for the tangent line. That's my equation for a derivative. Okay, so after you have your derivative, then what do? You need a point. How do you get the point? Plug it in, unless they give it to you. Sometimes, like the first one I did, I said it went through -2, 6. But the second one, I said it went through x is 3. So Carson had to go plug it in. But what do you plug it into? The original function. What do you think some kids plug it into? The derivative, because they don't get what they're doing. They find the derivative at 3 and think that's the point, and so be very careful. So we take and we find a point on the original curve. We calculate the derivative, right? We do the derivative at that point. So then now we're sitting there with point slope. So the last thing you should write is, then I write my answer in what form? Some of you just wrote then answer, but it needs to be in point slope form. So I would be looking for, find the derivative, find a point on the curve. If it's not given to me, plug the x in, right? Find the slope there, and then write point slope form. Those would be 5 things I am looking for. All right, we'll do a quiz on that tomorrow. Next concept's easy. All right, so we talked about when a function is continuous and when it's not. We said in order for a function to be continuous on our last test, f of c had to be defined, the limit from the left had to equal to the limit from the right, and they had to match up. The limit had to equal f of c. Now we're going to talk about what makes a function differentiable at a specific spot. So it's a little different, okay? There are times when you can't take a derivative. There's 3 scenarios where you can't take a derivative. If the function isn't continuous, you can't take a derivative there. How can you find the slope of a tangent line at a gap? There's no tangent line there. How can you find a slope of a tangent line at an asymptote, right? There's no tangent line there. So we're looking for no gaps and no asymptotes. And you can think those, but you usually don't write them. So what I'm telling you is if C is right here, and we've got a gap or a hole in the graph, anything that disrupts continuity, I cannot take the derivative right there. I'm not even defined there. If there was a gap there, I couldn't do it. If there was an asymptote there, I couldn't do it. So a function must be continuous. So here's my if-then statement from geometry. I said in order to be differentiable, it must be continuous. So I'm saying if differentiable, it was continuous, right? I'm not saying if it's continuous, then it's differentiable. I'll show you a continuous function that's not. All right, but I always tell kids, remember, because College Board likes to test that. I tell them, remember, differentiability means it was continuous. I tell them to think of Diet Coke. So it's the D that implies the C, not the other way around. All right, next, you can't have any sharp turns in the graph. It has to be some, this is kind of funny because I always call them cusps. I was an AP reader last year in Kansas City, which means I graded national exams. I think I told you that. But I was reading a problem where it had a question about differentiability, and it asked them if it was differentiable at a spot or not, and explain your answer. And we had a discussion for about an hour about what things you can accept. I said the AP graders accept all wording. They actually don't. There was a list of like 10 things they accepted and a whole bunch they didn't. Cusp was one they did accept, thankfully, because that's what I told my kids to write. But some of the people in our reading group had never heard of the word cusp for it before. It's book dependent. So they're like, okay, we have to figure out what we can accept here. They accepted sharp turns. This is what I mean. That is my issue. I cannot do a derivative there. They accepted sharp turns, sharp corners, the meeting of 2 lines at a sharp point, the apex of 2 lines. They accepted cusp. They accepted them. It's funny because then we had some students, 2 actually, in our big group we were rating, wrote doink point. So some teacher told them, oh, it's that doink point, and they wrote it. We didn't accept doink point because it's not even in the dictionary. So cusp actually has a definition, but we didn't. And some kids wrote shark fin. That came up, like, because when you don't know if you can give a point for it, you pose it to the group and say, would you give it for shark fin? And we're like, no shark fin. Right? Anyway, you can use the word cusp. And so also, you can't have a vertical tangent line, all right? So I'm not differentiable right there. So there are 3 things that disrupt differentiability. Continuity, lack of it, right? Sharp turns, which you can go ahead and call cusps, and vertical tangent lines. So loosely what I'm telling you is your function has to be roly-poly. Now, do not write that on the AP exam. Don't say yes because it's roly-poly. You can't do that. But what I'm telling you is you can't lift your pencil, you can't make any sharp turns, and you can't kind of go straight up. You have to keep rolling like a roller coaster for you to have differentiability. So this was going to be a website that I was going to go show you, but in the past years where I've gone there and clicked on them, everybody thought it was super easy. So what the guy does on here is he gives a function and he has a specific specific value of c, and he asks about these three questions. Yes, no, maybe. So I'll just put this one up there. Is that function defined at c? No. Is it continuous at c? No. Is it differentiable at c? No. All right, so in lieu of me logging on there, let's go do another one. And you don't need to draw this. Boom. Okay, is that function defined at c? Yes. Is it continuous at c? Yes. Is it differentiable at c? No, because of the cusp. Okay, so that's too easy. I already told you that a function has to be continuous in order to be differentiable. So if it's differentiable, it must have been continuous. And the contrapositive of that, if it's not continuous, then it's not differentiable. Just if I lift my pencil, if I have a gap there, we get that. This is the one that goose people up. Just because it's continuous, does it have to be differentiable? I just gave you one. Think of a parent function that's continuous everywhere, but has a cusp or a sharp turn in it. That's my best counterexample ever. Think of one of those parent functions that we drew in Unit 0. Which one had a very sharp corner somewhere? Yeah, absolute value. Yeah, that's a perfect counterexample. Counter. I had a cold when I typed that. There. Y equals absolute value of x is not differentiable at 0. Keep in mind, I'm talking about at this specific spot. It's differentiable here. I'm continuous over here. I have derivatives over there. But at that cusp, here's the reason. It has to do with a limit. I'm not going to get into that today much, but it's because I can't really tell you, is the tangent line this one or is it this one? And they're both very, very different slopes. Where if that was rounded like this, what's the slope of the tangent line? 0. But when it comes to a peak, is it the left or the right? I can't tell you. All right. So last page. I know the notes are long. Tomorrow you don't take notes. We practice graphing. Well, you take very few. So in your homework, it's going to say, tell me where this function is differentiable. Easier to tell me where it's not and then throw it out of your answer. So where on that graph is that function not differentiable, Kens? At 0. Okay, so this is my problem right here. Of the 3 criteria, which one is that one breaking? It's got a what right there? Say it. Vertical tangent, yes, exactly. This is the cubed root of x function. It is not differentiable everywhere. It has an issue at 0. My tangent line is vertical. Vertical lines have undefined slopes. Do you get why you can't, the slope's undefined when it's vertical. So we can't have any of those. So I would say negative infinity to 0 union 0 to infinity. All right, next one up. This function, which I graphed using Wolfram, I just threw it in there. Where is it differentiable? I can take the derivative everywhere. I can find the slope of the tangent line at any dot on there, except where? Negative 2 and 2. I can't tell you. It's too steep to the left and too steep to the right. Can I draw a tangent line up here where it's smooth? I sure can. And right here at 0, I'm great. Right here, it's very positive. I'm good. Right there, I'm confused. Right? I don't know. So you would say negative infinity to negative 2 union negative 2 to 2 union 2 to infinity. You just throw those two undifferentiable locations out of your answer. And lastly, I wanted to be done in 30 minutes today, but I got going a little bit talking about AP grading. I want you to put a gigantic star right here. Remember on the last test, I gave you a function. I told you I would, a piecewise one, and I said to tell me if it's continuous at like 2, right? And you'd plug the 2 in and plug the 2 in, and if it was the same, they sealed up, and you'd say yeah, right? If they were different, you'd say no, because the limit from the left isn't equal to the limit from the right. Is continuity enough to assure differentiability? No, Abby just said absolute value. We've got an issue. Right? So when it asks you if the function's differentiable, you need to confirm 2 things. I want you to draw an arrow. What must it first be? In order to be differentiable, it has to be what? Continuous. So you're going to confirm continuity the same way we always have. So the first thing you're going to do is make sure that there's no gap or hole in this graph. There's no hole because of that equal to bar under there. For the gap, I just go check. How high is this parabola at 2? It's at 2 squared plus 1. And then I go check. How high, or what is the y value of the line? And I go check, and it's 4 times 2 minus 3. If these are equal, I can continue to check if it's differentiable. If they're not, I just stop and say it wasn't continuous. Okay, so I've got a parabola meeting up at a line, and they are both meeting at 5. Does it mean it's differentiable? Not if 5 is right here, and then this guy takes a sharp turn, right? I've got a problem there. So I have to make sure that where they meet at 5, they do so seamlessly, as if you can't even tell where one started and the other began. As if at 5 right here, the line came in and took off like that. And it's taking a while to read my pen, but where you wouldn't even know that it was 2 of them going together. See what I mean? So I have to make sure that that's happening. Here's how you do that. In order to make sure that happens, you have to make sure that the slopes of the tangent lines as you come in are equal. Because if they're not, we meet at that sharp corner. Like if one of them's, 10 and the other's -2, I've got a problem. So what's the slope of a tangent line? A derivative. I have to make sure the derivatives are the same. You guys are really good, by the way. You pay attention, especially for this early in the morning. I love you people. I love you, man. All right. Oops, I forgot I have my headset on. Sorry. Okay. I can't be goofy when my headset's on. Oh, well. All right, so I just confirmed continuity. Now I'm going to confirm, and I usually tell kids to write if the derivative as I approach from the left is equal to the derivative as I approach from the right. So I'm just going to check, are they actually making that roly-poly seamless entry, or am I going to be cusping out? Okay, let's go check. What is the derivative of the parabola? Don't do it the long way. Quick, what is it? 2x. Okay, excellent. I want to make sure that the derivative when I come in from the left is equal to, what's the derivative of the line? Makes sense. The slope of the line everywhere is 4, so you don't really need a power rule. 4. I have to make sure that at this breaking point, which was at 2, those are equal. So we're going to put question mark and write at x equals 2. Are those equal? Yes or no? Yes. If my answer had been no, right, if this was 4 and this was 5, what does that mean? It means they're not meeting in that nice smooth manner. One's going to go wait, and the other one might go like that. You need to be able to do that. That was number 97 in your homework. All right, we are done. So what are we working on today? You are working on that homework assignment. This is for tomorrow. You're going to take notes for about 5 minutes. You're going to do that derivative draw until you can get 80%, and then you have some video notes to watch. So tomorrow I don't talk hardly at all. We're going to practice. But today, take out your book and go ahead and work. I don't know how much time you have. There's like 15 minutes. I'm sorry. Tomorrow you'll get more.